Hello, in this video we're covering independent events, something that we covered in some detail in our probability investigation, but in this video we're just going to look at it in a bit more detail. So I've stolen or paraphrased a definition from your textbook, and they say that independent or two events are independent if the occurrence of one event has no impact on the other and vice versa. We call them independent events. And my example I've chosen is rolling a die, then flipping a coin. Or it could be rolling a die and flipping a coin at the same time because we've got two hands. Whatever happens to the die roll, whether I get a 6 or a 5 or a 2 or whatever, has no impact on whether I get a head or a tail, and vice versa. So they're independent events. They're physically separate from each other, I guess. Quite a few people confuse independent events with mutual exclusive events. So I've just got a little bit of information here. So mutually exclusive means they cannot happen at the same time. So rolling a 6 and rolling a 3, that's, if you roll a single die, you can't get a 6 and a 3 on the die roll for a 6-sided die. So they're mutually exclusive events. They cannot happen at the same time. Whereas independent events, as per the example I just showed you before, they can happen at the same time, but they just have no bearing on each other in terms of the outcome. So that's the difference between the two. So what I want you to think about, you might want to pause the video. You might just want to think about it for a little while and then articulate your thinking afterwards. This comment down here, are mutually exclusive events, so two events that can't happen at the same time, are they independent? I've given you two different definitions, but it doesn't mean events can't be have more than one property. Are they independent, or are they dependent, or could they be either, depending on the situation? Which one of those three options? I'll tell you, it is one of those three options. Okay, think about it. We'll come back to it later. Just going to zoom out now. Keep it zoomed out. So the impact, and we covered this in class on Friday if you were there, the impact on this idea of an independent event is as follows. If we look at conditional probability, if A does not impact on B, if they've got two events, A and B, and they're independent, then the probability of A given B, remember that symbol means given, the probability of A given B must be the probability of A. In other words, it doesn't matter what's happening with B, probability of A remains unfazed. And I should say as well, I'm not going to go down the rabbit hole by doing too many combinations of this, but this would be probability of B, right? A and B are just two events. So that's important to note. And given that, we actually have a bit of an outcome that's really important to discover. It's the product rule for independent events. And this is how we discover it. If I look at probability of A given B, then what's our formula for working out that probability? Pause the video, write it down, look it up. I'm going to tell you in a second anyway, but all these sort of independent actions of your own sort of help make it right in your head. Okay, hopefully you looked it up and you got this. The calculation, the formula, is the probability of A intersect B over the probability of B. Okay, great. But for the left-hand side, we just said that the probability of A given B is just the probability of A. Makes sense from a logical perspective. And so I can replace that left-hand side probability of A given B with this probability of A. So I've got probability of A equals probability of A intersect B over the probability of B. Remember, A intersect B means that both events have occurred. And it means that the probability of A intersect B must therefore be the probability of A multiplied by the probability of B when A and B are independent events. Okay? And that's just a new formula for you there. Probability of A intersect B equals the probability of A multiplied by the probability of B. And this is one of those things which we call an if and only if statement. In other words, if I can show that the probability of A intersect B, if I can show that this value here is the same as multiplying the two probabilities together, then it must be that A and B are independent events. And if A and P are independent events, then the probability of A intersect B is probability of A times probability of B.